What's going on, guys? Welcome back to Classic Octane. I am Taylor. Today is day 6 of the 7-day CB550 build. So today and tomorrow, this sucker's got to be done. So today we are going to be working on wiring. So if you didn't see the last video, I got basically the battery box and the kind of main section of the wiring done in the back. But I was moving on to wiring all of our controls and headlights and signals and all of that kind of stuff, and decided I was going to do a more in-depth kind of, not necessarily a how-to, but I'm going to walk you through my thought process, what I'm doing to hook up every circuit, in hopes that this will demystify wiring for a lot of people. So this should all actually work ideally by the end of the day. I have my wiring diagram, which I'm going to have to use a mixture of 550 and 500 wiring diagrams, just because we're kind of using a main harness off of a 500 with some switches off of a 550. I'll kind of get into the differences and what we're going to have to kind of troubleshoot and figure out on our own. I also have the little wiring diagram that comes with our universal gauge, just so I can wire up all of our indicator lights. I have my turn signal diode that I'll explain when we get to that point. Some bullet connectors, my crimping tool, and I'm sure I'll need some like wire cutters and some other random tools along the way. But what do you say we go circuit by circuit and get this thing wired up? So I'm going to do my best to explain this in a simple way. Try not to repeat myself too much. Also, just full disclaimer, there's a good chance I'm going to say something wrong, or call something a resistor when it's actually a diode or whatever. So I'm just going to put that out there, that I don't claim to be the perfect electrician or being able to wire these things up. I'm just going to walk you through how I'm going to do it. We may very well hook something up wrong and have to troubleshoot what I did. And this is just kind of me showing you the process in hopes that you guys might get a little nugget here and there of useful information. So starting from the right side of the bike, we are going to start at the top, which is our kill switch. So a kill switch is going to be basically just turning power on and off to our coils. I've talked about this in some Will It Run videos before. Our coils need a 12 volt power source to operate. And this switch just basically gets 12 volts in. When it's in the on position, it sends that power straight to the coils. When it's in the off position, it breaks that circuit. And that's what kills the ignition of the bike, which makes your spark plugs not work, which is what kills the engine. So on classic Hondas, there are kind of a couple different kinds of circuits. So there's common circuits, which means there's a bunch of different connectors that all basically are connected together. One example of that is the solid black wires. On a classic Honda, the solid black wires are a key on 12 volt power. So it's full battery power as soon as that key is in the first position. When the key is off, there's no power to that circuit. So that allows us to tap into that for a bunch of different things. One of them is going to be our kill switch. We're going to operate some of the indicator lights off of that. Anything that we need a good power source for, that then is controlled by a switch after the fact. We also have solid green, which solid dark green is common ground, which means all of these connectors right here are in theory all connected to each other. So that's just a good common ground source. So we can ground our turn signals to it. We can ground the other side of indicator lights to it. I'll get into the indicator lights later because they're all not grounded. I'll explain that a little bit later. Just anytime we need the ground side of a circuit, dark green is going to be where we're going to go. And all of the rest of the wires are colored. So they're either a solid color like sky blue, which is for, I believe, the left side turn signals. Let me verify. Sky blue is for the right side turn signals, and orange is for the left side turn signals. Then we have, yellow with a red stripe, which is going to go down to our starter relay. So that's the kind of gist of the main wiring. And the beauty of using a stock harness is we can utilize a stock wiring diagram to kind of figure out where these wires are supposed to go. So starting with the kill switch, using the wiring diagram, I can tell that one side of the kill switch is a solid black. The other side of the kill switch is the wire I mentioned earlier, which is black with a white stripe that ends up running to our coils. So all we need to do is find a connector with a solid black for one side. Make sure the bullet connector is nice and seated, and then the black with a white stripe for the other side. Boom, that's it. First switch done. Next, we're going to go down to the headlight switch. So the headlight switch on this bike is going to be a little bit more, I guess a little bit different than what it would traditionally be on a CB500, because on a CB500, they normally just have the headlight and the tail light on all the time. So you turn the key on, boom, it's got power, it's on all the time. I'm using a CB550 right switch, which lets us actually turn on and off the headlight circuit. So all I really need to do to change that up is I need to figure out one side of the headlight switch and then the other side of the headlight switch. So I went ahead and did that. How I did that is I used my voltmeter. This is just a cheap one from AutoZone or whatever. Put it on continuity, which is the little Wi-Fi symbol for you youngsters. And all that does is beep when these two are connected. So I'm looking here, I know just based on my wiring diagram that one side of the headlight switch should be this brown with a white trace. The other side should be a black power wire. And this is a black with a red stripe. Again, just because it's a little bit different using this switch on a 500 harness. How I can verify that these are the two correct wires, put one on one side, one on the other side. We have no continuity. We switch our headlight switch on, like that. Now we have continuity. So I know that these two wires are connected together when the switch is in the on position, and they are disconnected when the switch is in the off position. So we're going to utilize that information to say, okay, we want power to come in, key on power from one side. So we'll hit that to the solid black, which we know for a fact is a common key on power. The other side is now going to have power anytime that headlight switch is turned on, which means this needs to send power over to our other switch. Our other switch has the high beam, low beam selector. So when we get to that side, we know, hey, power into that switch is going to come from this wire, and then it's going to come out either to the high beam or to the low beam. And I'll show you guys that when we get to the left side of the bike. Next up on the left side of the switch is the start button. So interesting thing to note on the start button, and I will show you how I figured this out on the wiring diagram, is the power, it's not a powered switch, it's actually a ground controlled circuit. So what I mean by that is on a power controlled circuit, there's power coming into one side of the switch. When the switch is turned to the on position, the power then comes out the other wire. This is doing that same thing, but with ground. So it's ground coming in one side of the switch, which is solid green, which is the wire that we have here. And then when the button is pressed, it's going boom, okay, send, ground. It's not technically sending the ground, but it's connecting ground to the other wire, which is, in this case, yellow with a red stripe. So how I figured that out on the wiring diagram, and I hope it's going to be able to focus on here, is this is the start switch right here. And you can see one wire coming out of it goes to this little symbol. And what that little symbol means is ground. That means you can hook that to the frame of the bike. You could hook that to any of our solid dark green wires because those are all common grounds. And then R/Y means yellow/red, or red/yellow, which is of course our other side. And that means when that button is pushed down, it's the same as if you took this yellow with a red and just stuck it right on the negative side of the battery. And that's what's saying, okay, boom, now it has ground. This yellow with a red stripe is grounded. And down here, if you looked at the actual starter solenoid, there is the yellow with a red stripe and a black wire going into it, which means black is our key on power. So as soon as you turn that key, our starter solenoid has power, and then it's getting turned on by grounding the other side of it. I hope that makes sense. Maybe as I continue to go, it'll become a little bit more clear, but we want to make sure that we have a good, solid, always grounded wire on one side, and then this yellow with a red is only grounded when that button is pushed. So to do that, we'll take the green side, go to any old solid green connector, and stick it in. Again, make sure it seats all the way. Sometimes it's helpful to have like a little screwdriver. something that's somewhat blunt on the end, just so that you can make sure it's all the way seated so these don't come loose. And then we're looking for a yellow with a red stripe, which is this guy hanging out down here for our other side. And I do have the battery disconnected right now because I don't want to start having power up here while we're fumbling around and hitting with screwdrivers. I don't want to short anything out. So I do have the power off at the moment. Later on, once this is all connected, then we'll switch the power on, look for any magic smoke, and ideally, if everything went together correctly, we have no issues. So that is actually our whole right side switch done. Let's move on over to, let's do the left switch first, and then we'll come back to the universal gauge, just because the left switch is a little bit more what you'd find on a stock bike. And then this is the wiring for the gauge that's going to be a little bit more complex, so we'll wait to do that third. So moving over to our left control. Our left control has the left and right turn signal, the horn, and the high beam, low beam indicator. So let's just start with the high beam, low beam indicator. So if you remember from our right side, that means we need to have power into that switch, and it's either going to hit power to the left, or sorry, to the low beam, or power to the high beam. Our power is going to come from our headlight switch. So black key on power into the headlight switch. As soon as you turn to the on position, that power then comes out the brown with a white stripe. It's going to need to go into this switch somewhere as one of these and come out in either one of two wires, high beam or low beam. Since I'm familiar with these, I know that this blue is high beam and this white is low beam. So those are going to be where our power comes out. Where our power comes in, ideally, would be this brown with a white stripe, but let's use our multimeter to confirm that that is what we need. Switched over to my bigger snap-on voltmeter because it has little clips which will make it easier to hold. So we're going to just clip one. Let's confirm it's working. Yep, clip one to the brown with a white stripe, and then the switch is currently in low beam, which means it should connect to our white. Uh-oh. Doesn't do it. See if it's connected to the blue. Nope. So it's not brown with a white stripe. Let's keep it in low beam. We will connect one side to the white because I know that that for sure is the low beam out. And let's just test a couple other of these wires and figure out what the other side of that switch is. Maybe it's brown with a blue stripe. Nope. Let's go through here. Solid brown. Yes. Test all of them just for fun. Nothing else. So now we know that the other side of my headlight switch is actually this solid brown wire inside of this connector that we're not going to use. So I can go there. Now in theory, I can switch this over to our solid blue wire, which should only get power when it's in the high beam indicator position. So we'll do that. Switch to high beam. High beam off, high beam on. So now we know which wires we need to connect. We need to connect that brown with a white stripe over there to this solid brown wire. So while I'm cutting off this connector, I could de-pin it, but these are like blade terminals and I need bullet terminals anyway, so we're just gonna cut them off. To talk a little bit about why this is a little bit different. So I mentioned earlier that on 500s the headlight is on all the time, and how it does that is it actually just uses the ignition switch. When you turn the key on, it basically connects the brown to the brown with a white stripe, and that turns on, it runs things like headlight, tail light, that kind of stuff. It also allows you to go to that third position for like parking lights or whatever. Again, I've talked about this in the past before. I don't really ever use that, but it's like if you go to that third position on the switch, it will turn on the tail light and just leave it on. We can still wire that up later if we so choose, but what I'm doing here is I basically am just utilizing that turn signal, or that, excuse me, that headlight switch to turn on a bunch of different circuits. We're going to use it to turn on, of course, the headlight. We also need it to turn on the tail light, and we also needed to turn on our backlight on our gauge so that it actually lights up the gauge at night when we turn it on. So we can't just connect this to, our solid brown wire, because if we just connected that, there would be no, gauge light, there would be no tail light. So we're going to need to connect this to multiple different wires. So let me show you that real quick. So what I've decided to do is this brown with a white has a multiple connector piece on it, and it's the one I talked about earlier that's the wires exposed. So I'm going to cut this off right here. We're not actually going to end up utilizing this. I'll probably put a little bit of electrical tape on it just because I do believe it's going to be key on power and we don't want it wailing around in here. What I'm going to do now is actually utilize this piece. I'm going to put a female bullet connector on one side, and then we're going to have it connected to the power coming out of the headlight switch. Then we'll be able to plug in our headlight power, our tail light power, and our gauge backlight power all to this one connector. So let me hook up a female end, and then we will find those other 3 wires to connect into here. Just wanted to show you real quick the connectors I use. I buy these little packets off Amazon. I will make sure the link is in the description for these proper bullet connectors. And they're basically just an open connector on one side. You use this crimping tool. Mine happens to be a Matco, but you can buy cheaper versions as well. And basically this little connector just fits into here. You can kind of get it started and hold it in there because this one is ratcheting. And then put in your wire and crimp it around. And what it does is gives you just a really nice, secure bullet connector on there. So part of it clamps onto the wire, kind of shielding. The other one crimps directly onto the copper, core of the wire. And then now you have a bullet connector. And in this case, I left off the little protective, sheet around it so I can show you, but I'm going to stick that over, and then that will give us a nice, good bullet connection that we can then tap into. So we have our female connector put in now. So now we have 3 female connectors to hook up our 3 different circuits. So how we find those circuits, one I just showed you, solid brown wire happens to be our power in to the high beam, low beam indicator switch, whatever you want to call it. So that's going to be one that we can just put a male end and we'll go in right there. The next is going to be power to our tail light. So you can look at the wiring diagram and see that power to the tail light on this bike is solid brown, happens to be the exact same color. How I can easily find that wire up here, one is there's only one solid brown wire that's coming from the main harness. But if we want to confirm that, I'm going to continue to use my multimeter on the continuity. So we have it connected right here to that brown wire. Such continuity, we'll take our other side and go back and touch this brown wire that goes to the tail light. Let's see. Oh, I turned my beep off. There we go. So we can now see that for sure that brown wire back there connects to this brown wire right here. So that will be the next connection we'll make. I'll have to cut off this female end and put on a male end of a bullet connector to go into there. The next one is just slightly more complicated because it's using our universal gauge. So we can pull out the tiny little wiring diagram that comes with our new gauge, and we're looking for the backlight, which on the right side here, and then it says the 2 wires going into it. Positive is the orange wire. Positive is the orange wire, negative is the black wire. So that means for our indicator light to turn on when the bike turns on, we want power going to our orange light only when the headlight is turned on. So that is the circuit we are looking for. So this orange is going to be the 3rd wire in our connection, which means I turn the headlight switch on, it sends power to this orange wire, which is the power side of our backlight, to the switch that determines whether it's high beam or low beam, and to our tail light. Hopefully that will make sense. So let me connect it, we'll move on. Power circuit's all hooked up. Now I want to continue for our headlight wiring. So now Low beam will have power coming out of the white, high beam will have power coming out of the blue. This is the little connector that comes with the new headlight we're using. Very conveniently, we have a blue, a white, and a green, which means green, common ground, blue, high beam, white, low beam. So we're going to be able to very easily just match these colors, put a female on this one, a female on this one, male on the ground so that we can go into one of our common ground circuits, and that will be our headlight wiring done. Headlights done. Let's move on to what's next down the thing. Turn signals. So turn signals are a little bit more interesting. Same basic theory. Of course, it's all, you know, DC power, which is what we're working with here. But for turn signals, we need that power to turn on and off. And what that does is that uses the flasher relay. So what a flasher relay does is it basically gets power in one side, and then when it detects a current draw on the other side, it flips on and off. That's what that tick-tock, when your signals are doing. That's it pulling enough current to trip it, and then the current goes away because the light's off, and then it turns it back on. And that may be backwards. Again, I don't have a degree in electronics, but that's my understanding of how it works. So for a bike that runs LEDs, LEDs draw a significantly less amount of current than a typical incandescent bulb does. So that's why you can't utilize your stock flasher relay with LED lights, because the light will just be on and it won't flash. It'll just stay on all of the time. And that's because it's not drawing enough current to trip that relay to go back and forth. So we utilize an electronic flasher relay. They're very cheap, less than $10. The link is in the description of the one that I happen to use. Feel free to use any one you want. What I like about the one that I use is you can actually vary the frequency of the flash, and you can match it up so that if you're using some incandescents and some LEDs, you can actually change it. You can have it flash, you know, faster, slower, whatever you want. So what that means is one side of our flasher relay is a solid black. Everybody in unison, what is a solid black? Keon power. Okay, I'm losing it. So it's solid black, and the other side of the flasher relay is gray, is a gray wire. So let's try to find our gray wire. Fish on through. Here is our gray wire. So what that means is this is power to our turn signal circuits that is going to switch on and off with that relay. So this is going to be our power in to our turn signal switch. Are we going to be lucky enough that the turn signal switch is going to be power in gray? Oh, we have a gray wire here, so we can test it. Let's connect our multimeter again. Gray on one side, and then we have orange and sky blue. Orange is left side turn signals, sky blue is right side turn signals. So let's just go with orange, which is left, right? Yes, left. So in theory, I should be able to put this to the left and it should beep. Oh my gosh, we did a thing. Now we'll go to sky blue on the other side, and if I flip the switch to the right, oh my gosh, look at me. So what that means is I need to connect our gray to our gray coming from a flasher relay, which means I'll just put a male bullet connector, it'll go right in there. And then we will have our two individual circuits to run all of our signals off of with the orange and the blue. So let me connect this gray, and then we'll move on to what to do with these two guys. Got our gray connected, so now we need to power each individual side of the turn signal. So much like our headlight switch, we want a few things to happen when we put this indicator into, say, the left turn signal position. We want the front left turn signal to turn on, the rear left turn signal to turn on, and we want to utilize our turn signal indicator that's built into our gauge, the little light that flashes on the gauge to remind you to, hey, your flasher's on, don't forget to turn them off. So we need to split that power 3 different ways. The orange wire is for our left turn signals, like I just talked about. It does happen to have a multi-connection piece on it, so we're going to utilize that. So I need to connect the orange coming out of the switch to that connector. I need to hook up the power to the front left turn signal, the actual little signal we have mounted on the side here. So we'll find where our power is, which on this one happens to be a yellow wire right here. That will give us power to our front light. The main wire to this is running to the back of the bike, which is going to be where we connect our power to the left rear turn signal switch. And the last thing that's going to be plugged into here is one side of our turn signal diode. So this is what I mean when I say turn signal diode. So this is a piece that I make mainly because I had a hard time finding them online. So I decided to kind of make them and sell them on my website. I sell them for $5 a pop, shipped, which means I make $0 basically on these, but I make them just to help you guys. So I will continue to try and make them as long as I can. They're not super labor intensive, but you know, it does take some labor and without any real return. So I hate to do this, but I appreciate if you were to order one of these, like maybe get a pack of stickers too. You know, it'll cost you $10, but at least it'll help me out. Or make your own. It's basically 2 diodes in here. And if you're to give you the 10-second version of what a diode does, it only allows power to go in one direction. So when you connect it up, it only allows power to go one way. So when I design these, I have a red wire on this side connected to a diode connected to one side of this white wire, the other red wire connected to a second diode, and then connected to the other side of that white wire. So what this is allowing us to do is we will connect one of these red wires into this orange connector, which means when our left turn signal, circuit is turned on, it will send power to both the lights. It will also send power through this red wire that will then come out of the white wire without coming out of this red wire as well. If all 3 of these were just connected right in here and soldered, as soon as this had power, all of these would have power, and we don't want that. We only want the white wire to have power. So you connect this to the orange circuit, it will then send power out of our white wire, which we will use to connect to the power side of our turn signal bulb. And I'll get more into that here in just a minute when we go to the gauge, but basically one side of this is going to get a bullet connector to go to the orange connector. The other side is going to get a bullet connector to go to our sky blue connector. So one's going to be left, one's going to be right side. I hope that makes enough sense for you guys, but now I just need to get basically 3 male bullet connectors and connect the whole left side circuit together with this. I got my right side turn signals hooked up exactly the same as the left. One side of our turn signal diode goes into that connector that runs to the back of the bike. Power to our right front turn signal goes to there. The wire that we're utilizing is a sky blue that runs to the back that we will connect the power to the right rear turn signal, and so on. So that is ready to go. We're moving on to the horn, which brings up an interesting issue that I want to show you how I'm personally going to address it. There's a number of ways to do it, but horns operate much in the same way a starter solenoid does, where it gets key on power all of the time, and it's just looking for that ground signal to go off. So on these Hondas, it's actually 2 wires right by the coils here, a solid black, which is key on power, and then a light green. The light green is going to be the ground signal that comes from our button. So when we go to the switch, and I had to pull it off to show you guys, on a stock bike, it gets that ground directly through the handlebar. So it's connected to the handlebar. There is a little stud in these that goes, you have to drill a hole into the handlebar. It goes in there, that's where it gets that tight connection. That gives you not only the ground, but also helps this from spinning in place. So that normally gets the ground. When we're running a clip-on like this, the clip-on itself is painted or powder coated. The mount is painted or powder coated, which means we're not getting any ground in this bar. So there's a couple of different ways we can fix this. One is we could grind some of this paint and powder coating off to get it to a solid connection from the fork tube into the mount into the handlebar. I don't really want to do that. So what I'm actually going to do is, since we are not utilizing a couple of wires in here, so there is a sky blue with a white stripe and an orange with a white stripe that come through here that are traditionally connected to the kind of turn signal circuit, and that's what turns on your turn signals as like a daytime running light kind of thing. I don't typically utilize those, so I'm actually going to just steal one of those wires because it runs from our headlight into this switch, and I'm going to ground it. So I'm going to cut off this side, put on a little eyelet terminal, and we're going to just have it go right to one of these 3 mounting screws in here. What that's going to do is give me a solid connection into the main housing, which is what would traditionally be grounded. I will take the other side and run it to our solid dark green, which is the common ground. And what that's going to do is going to ground our housing, which then is going to ground one side of our switch. The other side of our horn switch, which happens to be a lighter green color, will be grounded when the button is pushed, which will ground our horn, which will make it go off. So I hope that makes sense. This is something that you wouldn't traditionally do in a stock style bike, but since this is a custom with clip-ons, it's something we're going to have to kind of run ourselves. Show you my handiwork here. So I utilize the orange with a white stripe. So hopefully you can see in here. Now it goes to a little ring terminal that just goes right under one of our mounting screws. We should still have sufficient clearance to be able to mount it. So that's going in. The other side I just put into any solid dark green, which means now if we put our multimeter continued on continuity, anywhere I touch this, it should beep, because I'm just, you know, whatever, grounding off the engine or any other part of the frame. And then we're going here. All of our mounting screws, including that little stud in the middle, is now grounded. So that means 1/2 of our horn button is now grounded. The other side is that light green, which we will connect into the same light green that runs right back to here, and then that will run to the horn. So hopefully that all makes sense. We now have a ground controlled circuit in our left switch that will operate our horn. I actually have to go find a horn because I don't have one on this bike yet, so we can't hook that up, but won't worry about that. I'll button all of this back up. That should be everything on the left-hand switch. Now we can move to the gauges. We are ready to move on to our gauges, and I hope you guys are still with me. I know that this one is going to end up being kind of long and obviously very technical and a lot of the same shot with me just talking. So I hope this is all making sense to you guys. So for the gauges, there's technically 5 lights in the gauges that we need to light up. One of them we've kind of already started, and that's the backlight to the gauge. That's the one that just lights up all the numbers so that when the headlight is on, you can see it. So that just needs, like all lights, a power and a ground. So that light is going to get power. We already connected it to our headlight power, which was this orange wire. The other side of that is ground, which we remembered from our little diagram is the black wire. So before I just put a bullet connector on this and connect it into our dark green, I can kind of kill a few birds with one stone and connect a couple of our grounds together. But a very important thing to note on these universal gauges is it's not as simple as all of the grounds on the lights go to one and then you plug in the power to each individual light to whatever their, you know, respective colors are. And why that is because the, let's see, the backlight, the turn signal, and the high beam indicator will all share a ground because they're getting power from either the headlight circuit, the high beam circuit, which is actually separate. One has the backlight, one is our bright blue high beam indicator that's going to be connected into this blue wire. And then the last one is turn signals, which gets the power from our diode. The neutral light and the oil pressure light actually have a common power and they are controlled by the switches. So the neutral switch grounds that circuit whenever the little selector, and I can show you guys that, and I've showed it in the past, it looks like a little cam lobe. Whenever that little cam is in the neutral position, it grounds that circuit, and that means it grounds that one side of your light, and with common power on the other side, makes your light go on. Exact same thing with an oil pressure switch, is when the oil pressure is low, the light is grounded, that switch is grounded, which means your light is on. When the pressure builds, it actually opens that switch, opens the circuit, turns your oil light off. So it's not as simple, as I said, of being able to just hook up all the common grounds, because you have to remember the neutral light and the oil light are ground controlled circuits. And I know that was a lot of information in the course of like 90 seconds. I hope that all makes sense. I'm gonna start to wire it, and if it didn't make sense, hopefully it will become more clear as we go. Grab my little wiring diagram. So we're looking for our common grounds first. So we have the backlight, as I mentioned. Black wire is the ground. Then we have the high beam, which is blue with a black stripe. Here's our blue with a black stripe. That's also going to be a common ground. And then the last one is our turn signal indicator, or they call it a winker on here, is our yellow with a black stripe. So we'll find yellow with a black stripe right here. So these three can be connected together. We'll put a male bullet connector on here, and then that will run to any of our dark green connectors. Now that we have our common grounds, we're just going to go down the list. So we'll start with our turn signals. So that's going to get power from our white wire on our turn signal diode. Quick reminder, this is just getting power from each individual turn signal circuit, but is not allowing power to transfer over to the other side. That way we don't have all four of our flashes going off at once. So we need to connect that wire to our yellow wire, which is the power for that light, which is right here. So one's going to get a male, one's going to get a female bullet connector, and we'll connect those and we'll move on. Now we'll do the high beam indicator. So high beam indicator grounded on one side already. We need power, which just gets power when the high beam gets power. So we kind of messed up because we already connected our high beam to the high beam. I got ahead of myself. So we'll need to cut one of these connectors off. And then what we can do is just connect the wires together and then put them in. I'll probably do it on this guy. You know, cut this wire off, wrap this wire, and our high beam is a blue wire, so it's also going to be blue. Together, put that into a male connector, and it'll go here. And that way, basically, all three of the wires are connected instead of just the two. And that will give us the power side of our high beam indicator. That's done. So now we have our turn signal indicator done, our backlight done, and our high beam indicator done. So that leaves us the two ground controlled circuits. So for the two ground controlled circuits, oil and neutral light, we can connect the power together, and that's going to go to one of our solid black key on powers. So the power for the oil switch is the red wire. Power for the neutral switch is the green wire. So right here and right here. So we will connect these two together. And then we'll put a male bullet connector on here, find one of our solid black open terminals, stick that right in there, and then I'll show you guys how to identify the trigger wires. I happen to know them off the top of my head, but I can show you probably on the wiring diagram how to identify the oil pressure switch and the neutral switch wires that are coming from the engine. So we'll start with oil. So we need the ground side of the oil light, which is oil ground red with a black stripe right here. So that's the ground side of our little indicator light. So now we need to know which wire runs down to the oil pressure switch. I happen to know off the top of my head, this is dark blue with a red stripe. But how you can figure that out is a couple of different ways. One, you could use your continuity on your multimeter, connect it to one side, go down to the wire, and connect it onto the oil pressure switch, see if it's the same one. Just see that, on this bike, in theory, it should be a blue with a red that's going right to our oil pressure switch. Or go to the wiring diagram, oil pressure switch right here, L/R, that is blue/red. L is blue because B is black. So blue/red, oil pressure switch, you can see one side of the switch has a little ground symbol, and that means it's grounded, and then that is what turns on our light. So this dark blue with a red will be connected to the red with a black stripe. Exact same process for the neutral light, which I happen to know is this green with a red stripe right here, but you can follow the same path of doing it on the bike, or you look at R/G, which is red/green for the neutral switch. So that's how I figured it out. So you'll want to connect that one to the neutral ground, which is green with a black stripe. Last few connections to make in here. We need to ground our turn signals. So fun change up. ground on the turn signals is a solid black. Don't connect that to another solid black because it will not work. So this needs to go to a green for the turn signal. Any old dark green will work. This is one side. And then we have the dark green, or sorry, black from the other side turn signal, which is this little guy right here. We'll just wrap him around and go right into this one. And then that is it on this particular bike because I'm running a stainless brake line that runs from our master cylinder all the way down to the caliper, which means we will not be able to utilize our factory brake pressure switch for our brake light, which would traditionally go to this green with a yellow stripe. So if you use a pressure controlled switch for your brake light, that's where it would connect, or it would go to like a switch on the brake lever itself. Traditionally, those switches will have power, solid black on one side, and will send power to this green with a yellow stripe, and that's what turns on your brake light. This bike, we will just be utilizing the rear brake light switch to activate the light. Anywhere that I've ever gone in Texas, gotten state inspections, all they care about is that your brake light comes on and off. So you will have to remember when riding this bike that you'll have to use the rear brake at the same time for your brake light to work. This probably honestly is not the way to do it. It's just because of the parts I have available. This is how we're going to have to run it. So I might look into ordering some kind of pressure switch for me to be able to maybe hook to the end of the master cylinder and use that. Otherwise, I'd have to get a whole new master that has the brake switch built in. So we'll figure out some way, probably in the future, to have the brake light be able to operate off of the front or the rear brake, just for the safest operation. But for as of right now, to get this bike running, this is what we're going to have to utilize. So this does run that front brake switch. Again, make sure to connect that. It's much safer to be able to have it that way. If you're just cruising, you're just using the front brake, you're not using the rear brake, you still want your brake light to come on for obvious reasons. So that's the wire for that. Before we hook up our battery, I went ahead and hooked up our rear brake light switch as well. So how this switch works is it is a power, common power, black on one side, and it's that same green with a yellow stripe that we were just talking about for the front switch, for the rear as well. So that's how this circuit works, is it can either get power from the rear brake light switch, which is on the lever, or a front switch, which is either from a pressure controlled switch or on the front brake lever. And all that's doing is when this is pulled down, the little plunger, it's just like you pushing a button. It's connecting these two, which is sending power to our green with a yellow stripe. That then goes to the power wire for the brake light. So I can't hook up my points yet because we are going to be putting an electronic ignition most likely this afternoon. And that's where our yellow and blue wires right here will come from that. And those go up to our coils. Let me show you real briefly what I did in the back here. On the back is just kind of temporarily wired up, but basically we have 3 wires that come out of our tail light: ground, power for the tail light, power for the brake light. So black is ground on this light, as it is on most aftermarket lights. And then there's a blue and a red. I honestly don't know, and there's no wiring diagram with this. I don't remember which one of these is power for the tail light and brake light. So what I'm going to do is just hook up red as the tail light and blue as the brake light. And when we test it, if one ends up being brighter than the other, the brake light is obviously supposed to be the brightest one. So if it's not correct, I can just switch those two. It's kind of the easiest way for me to figure out which one it is. We could also hook up power with a power probe or a little battery and test it as well, but this is just as quick. I also have our rear turn signals right here. Exact same setup as the front. Yellow goes to light blue for the right for power, and then the black is ground, which is a dark green. On the left side, black goes to the dark green, yellow on this side goes to orange, which is the power for the left side turn signal. So that should be all hooked up. I believe I have everything apart from the horn, so I will grab a horn just so that we can test pretty much everything on the bike. I did put oil in the engine as well, so we should be able to test not only our start button, but also our oil pressure indicator as well, and determine if we need to get in there and mess with those or not. So I'm gonna find a horn, and then we'll hook up the negative side of the battery, cross our fingers, turn the key, see what happens. Got the battery hooked up. Now it is testing time. It's always a little bit nerve-wracking because you don't want to, if you had hooked anything up the wrong way or shorted anything, you've got to be quick on the draw here to make sure you turn stuff off. You don't want anything heating up. In theory, our main fuse, I believe it's 15 amps, should protect us from anything going too crazy, but let's see. Okay, we're good. Our neutral light and our oil pressure light are on, which is exactly what we would expect because the bike is in neutral and there's no oil pressure because the engine's not running. Cool. So far so good. Let's go for headlight. So I should turn this on. Our headlight should come on, our gauge light should come on, and our tail light should come on. Headlights on, gauge lights on. We have a light on back here. Again, I don't know if that's the tail light or the brake light. So let's hit the brake light and see what happens. Doesn't look like anything happens when I hit the brake light. So that means that's probably our brake light is on right now, which means we might need to switch those two wires. Let me try high beam. Bulb changes to high. Our high beam indicator comes on, and the tail light is still on. Sweet, that's so far so good. Let's turn that off. Let me switch the two power wires on this tail light. Okay. Let's try this. Yeah, that's dimmer. Now we'll hit our brake light. We need to adjust our little switch over here, but tail light, brake light, tail light, brake light. Sweet. So we turn our off. Brake light works. What else do we want to do? Let's try signals. We'll go for left signal. Uh-oh. I got no left signal. Let's try the right signal. Ooh, its light's very dim. You know what? I want to see if it's just the adjustment on our relay. So let me turn the right signals on. On the bottom of this relay, there is a little kind of Phillips, kind of like a potentiometer kind of thing that we should be able to turn carefully without, I don't need a flathead, without grounding anything. When you're in here with a screwdriver, make sure you're not touching starter solenoid things or. Turn this and see. Interesting. Kind of flashes for a second and then stops. So let's almost had it. Stand by. Here we go. Now we got a right front turn signal, an indicator light, no rear turn signal. Oh, just got a loose connection here. Okay, so my bullet connector is a little bit loose back here. I'm just going to need to close it with a piece of, some pliers or something. But we have right turn signal. I'm not seeing any left turn signal. Should be orange. So that's interesting. Let's dive in. We'll keep going real quick. So we got right turn signal for sure. So we can dive in and see what's going on with our left turn signal. Last thing to test is the horn. Horn works. Actually, we'll go ahead and see if the starter system works as well. We're in neutral. What do you know? Well, that didn't take long to figure out. All I did was look, and my orange wire is just hanging out down here. It's not even connected to anything. Somehow I must have unplugged it. So let's plug that back into this circuit with the rest of the orange wires and see if that fixes our problem. What do you say we try it with our left turn signal wire actually plugged in? What do you know? How crazy is that? The turn signals work when you plug them in. So we got left turn signal up here. That means we should have a left turn signal back here, and we do. We should have an indicator light flashing, and we do. Turn it off, turn the right side on, indicator light stays on. Flashy, flashy. And then this one I told you is a little bit loose. So if I get the wire in the right position, there we go. So I'll tighten those up. Sweet guys, everything works as it should. I'm gonna go ahead and jump onto the ignition system now. My original plan was to go with an electronic ignition. I had this PAMCO unit kind of laying around for a while now, and I was just about to kind of grab it and install it. And I'm just not crazy about the the quality of this product. I mean, if you look at this thing, it's just like two kind of chips, and it looks like a prototype of an electronic ignition, if that makes sense. It looks like somebody put this together in their workshop to figure out how it works, and then they're gonna like send it off to get it manufactured. I'm just not crazy about the quality. I've shown Dyna ignitions in the past, and I am in love with those. And we may end up putting one of those on this bike, but because I don't have one of those in stock right now, I'm just gonna put the original points back on. So we're gonna probably get rid of this, or I don't know, maybe we'll try it on another project just to be the guinea pig, but this one I'm just gonna go back on with the stock system like I mentioned, since we know from the Will It Run video that this whole setup, points, condensers, and everything are totally operational and in good shape. Battery's been charging for a little while. Let's see what happens. Fingers crossed. Oh yeah. checking the charging system. It's working. 13.6 volts at idle. Not bad, not bad. It's smoking a little bit because when we worked on the engine, we had it upside down and kind of all around, so I'm sure some oil ended up getting into the cylinders a little bit. Also, there's going to be a little bit of oil and coating and stuff on the inside of the exhaust, so I'm not worried about the little bit of smoke that's coming out. I trust it will clear up with, like, you know, another 5 minutes of running. You can burn off all that residual oil and everything, and then it'll be good to go. But how about that? We wired a bike and it actually works. So I'm actually going to do something I did not expect to be able to do a week ago, and that is I'm going to call it a day early on this, because the only thing I have left to do is the gas tank, which I don't want to do in today's video because I don't have enough time to really start it and finish it today, so I'd rather it just be the first part of tomorrow's video. So we're going to do that, and then I mean, I don't really have anything else to do after that. I did make a mistake. The air filters I just got these like standard pod filters, and I guess I've been out of the game on CB550s because really it's been like 2 years almost since I built one. These don't clear the frame. You got to get the like collapsible foam ones that are a little bit shorter, so you can see them pulled up right there. I'm going to have to order those, so unfortunately they're not going to be here in time. That's not really going to change all that much. I can still sync the carbs and everything because pod filters really don't do a ton as far as airflow goes. And I'm still going to test ride the bike tomorrow without any air filters, just around the neighborhood. So I did make that mistake. Other than that, I started making myself a little list. Gas tank, I'm going to sync the carbs tomorrow. Air filters, and the rest is just adjusting the rear brake. Once I kind of get to ride the bike, I can see it. It seems like it's going to be good, but it's just tighten the tail light, you know, put the seat on. It's 4 minutes worth of work, so I'm really pumped. But I am going to start it one more time for you guys, just because you guys have been awesome in watching this series, and I don't want to let you go without hearing it one more time. Oh yeah, she sounds nice. And again, tomorrow we'll do the sync, and we can also get into the air fuel mixtures a little bit. I got a little bit of popping on number 3, so we can address that kind of stuff. But that's going to do it for today's video, guys. This project is just about done. I'm very, very excited. I appreciate everybody's support for the millionth time. You guys have been totally awesome. We just hit 40,000 subscribers. We just hit 6,000 Instagram followers, and that is a lot because of this series, but mostly because of you guys. So I appreciate it. I will see you guys tomorrow for the final day of the 7-day CB550 build.